All right, it's Sunday night, and the results from the frequency measurement test have been posted. So I printed out just a section of a listing of all the stations and what they got. And so here I am, Whiskey 6 Sierra Kilo Delta, and on the close station, the W8 RKO, minus 0.13 for both 80 and 40 meters. And that's kind of curious. Yeah, I'm thinking that there was Doppler involved, so I'm off by some amount. Um, and potentially the Doppler was the same, and so whatever accuracy I got is also added to the Doppler. So I could have been off by, zero point zero 0.05, and there could have been zero point zero 0.08 of Doppler, both times. And so that's why I'm thinking it's Doppler, and that's the same. The K5CM, it's a big mystery. So I was 0.06 on 40 meters, and on that one, things looked really good. Here's where the test was. But then on the 80, weird, off by minus 99.36. And the 99 is troubling. It's almost as if somewhere, everyone else had 154, 153, 153. I had 53. So it makes me think that somewhere in my setup, I was off by a hertz, by 100 hertz. Because if I look at the noise that I had, plus and minus, 2 to 3 hertz. This is where the test is, and so it's up 2, -2, and so I should be in the ballpark. I'm not sure why I'm off by 100, and I'm thinking, well, maybe I measured, some other station that just happened to be broadcasting in that band, and they, went up a bunch to avoid it. But I do remember, if you look at the spectrograph, of course, this isn't the actual test, but when they're here you can see this is WWVB. You can see this broken line, and that's what the Morse looks like. You can almost read the dots and the dashes if it's Morse code. This is actually time pulses, and then when they do the actual test, it's a solid tone. And of course, heat of battle. My memory is kind of fuzzy, but I kind of remember that the 80 meter test had a solid line, and it wasn't Morris CW anymore. But nonetheless, I'm off by 100, and I looked at my data, and I had the issue with the software not capturing what the receiver frequency was, and so if my receiver was off, if I said it wrong, by 100, it wouldn't matter because I'm measuring the delta between the receiver and what's coming in. It's this, and so even if the receiver was off, I'm measuring this delta, and that delta that I measured was, minus 147. That's why I got 53 hertz, and so the receiver couldn't have been the thing that's off, and that's the thing that you wind the dial and you have to actually set the frequency. The other thing that could have been off was if my GPS was up by plus 300, not plus 200, and I'm not sure how that would happen, because when I set the GPS frequency, here the reference for the first test was 35, 98, 200. I just bumped up the 1,000 digit by 1 to do the second test, and there wouldn't have been an opportunity for me to have put the selector on the 200 and made it 300 by mistake, because when I started the test, I put in 70, 64, 200, and so this 200 was consistent. I only dialed down. I dialed up by 1 to do the next 40 meter. Then when I did the 80 meter test, I put in 35, 98, and clearly, that first test, um, the right value was in there. And so I just had to change um, on the oscillator that one digit to a 9, and it wouldn't have been at the 200. I don't know how I could have changed the 200 to be wrong. And again, if the receiver was set wrong, it wouldn't matter because I'm measuring the delta between the target and the GPS DO. And I look at my data here, and I'm showing 53. So I'm not sure where that 100 came in, unless it's just some weird coincidence that someone was transmitting at that frequency, and that's what I measured. And I'm zoomed out. See if I'm zoomed out. And I'm not zoomed out enough to miss it. If it was really 100 more, it would have been on that waterfall. So I have no idea what happened. I was worried that I was going to be, subjected to the noise that was on the 80 meters. So, okay, well, anyway, so, what do I think about the results? I'm pleased. I like the fact that that these two numbers for the one station are identical, so they have the same error offset, which I'm attributing to Doppler. I'm not sure absolutely, how far I was off on the frequency, but at least, the consistency was there. And on this other one, the, 06, I'm happy with that also. The 100 will always bother me. And I think that for next time, I'm going to actually have a checklist. And so I can actually, write down and I make sure I have a proper procedure, which I followed, but, let me write down what I actually did and take a picture of the setup of the GPS disciplined oscillator and take screen captures of FL Digi and, and what the radio was doing at the time, and, figure out this frequency offset business that I sort of didn't like, the way that affected what my raw data looked like. But in terms of the project, yeah, I think I've met my goal. Yeah, I wanted to get within 0.1 hertz and 0.13. It's not within 0.1, but there's Doppler, and I'm not sure what the effect of the Doppler is. Here is Doppler, and it can vary. At least at the 5 megahertz when I was doing this, it can vary by as much as 0.2 or 0.3. So, the Doppler portion, I'm certainly within that error bar on my results. And if I look at just some of the other folks that did this test, these guys, well, his 40 meters was bad, but this guy got, a hertz. There's me. This guy, quarter hertz. This other guy, he was in Arizona, so he heard that station better. He got really close, got closer than me. And so there's a spread there. I haven't gone through and see how I compare to everybody else. I sort of don't care. But I'm in the I don't know, top half for sure, and probably better than that on a lot of stuff. Here's some guy that had Bodnar, and he got minus 0.11 and 0.81. So that's kind of like how I did, and he was spot on this one. Of course, Ohio is close to where KC5 CM is. So there's less Doppler effect, maybe, I don't know. But that's my comparison. He got similar results to me. This guy doesn't say what he got, but I'm sort of here's a guy with a flex radio. He didn't do as well. It's certainly comparable, and it's something that I made, and so I feel really proud about that. And it was a very, very fun project. It's not the result for me. It's the journey. I mean, I have the finished product, but then when I look back, I have how long, I have pages and pages of notes about all the investigations that I did during the development of the project, and a lot of, fits and starts, and just figuring out, I designed this thing. How does it actually work? What are the sources of error? How can I control that? Just a lot of investigation, a lot of good science, a lot of engineering, working on the GUI, trying to what things do I need to display, what fields do I have? I like the phase, display where I had to make my own LCD characters and load that into the LCD ROM. That was a lot of fun. Just again figuring out how stuff works, building it. I didn't do this DAC adjustment where I could have finer tuning control. I never implemented that, but I simulated that in Spice to get the values of the resistor. I had a lot of fun. I had a lot of fun building it, documenting it. It was a good project. It was more investigation and science than the Nixie clock. Nixie clock was just a lot of cool building and clickety-clack relays. But this one, again, homemade device, and I get within 0.13 hertz of some signal coming from across the country. I think that's pretty cool, and I had a lot of fun. And the next one is in April, and I'll work on my procedure and my checklist, and I'm gonna do it again, and I'll report the results. There's probably gonna be one more video on the next time, and that's always gonna be a mystery. Anyway, it was lots of fun, great project, and glad people have been paying attention. Right? Thank you for watching.